This video is going to explain you about concentration of solutions. At the end of this video, we will be doing calculations related to the concentration of solutions as well. What is a solution? A solution is a homogeneous mixture of solvent and solids. Believe me, almost all the liquids that you use day-to-day life are solutions. But in chemistry, when it comes to a solution, it has to be a homogeneous mixture, which means the solutes are evenly dispersed in a solvent. You will see a clear solution, obviously. Let's have a look at the particle level view of a solution. Here we have the solute molecules and the solvent particles. When you dissolve the solute molecules in solvent particles, they will disperse evenly throughout the solvent and producing a mixture like this. Let me show you a copper sulfate solution. You can see here the clear blue color solution in which copper sulfate is dissolved in water. Can you tell me several solutions that you can think of? Yes, dissolving sugar makes sugar solution. Dissolving salt makes salt solution. If you dissolve sodium hydroxide in the laboratory water, you get sodium hydroxide solution. Aqueous acids. Not only we dissolve things in water always, we can dissolve substances in other solvents. Example, you can dissolve wood paint in thinner, producing the paint you want to apply on wood. The use of a solution depends on the properties of solution. What are the properties of solutions important for us? Sometimes it's the intensity of color. Yes, in day-to-day life, sometimes it's the taste, but not in the laboratory. Density of the solution. Boiling point of the solution. So what are the parameters that are going to decide these properties of solutions? For example, what is going to decide the sweetness of sugar solutions? The salt taste of the salt solution. The intensity of color of copper sulfate solution. I know what you think of. Yes, that parameter is the concentration. Let's try to understand what is meant by concentration. These are two solutions of copper sulfate. Solution number 1 is made by dissolving 1 gram of copper 2 sulfate in 100 cm cube of water. The other one, 3 grams of copper sulfate in 100 cm cube of water. Which one will have higher concentration? You can clearly see solution 2 has a greater color intensity, which means this has greater concentration of copper sulfate in the solution. From the observations we can conclude that the solution 2 is more concentrated, and also it's understood when you have more solutes dissolved, the concentration is higher. But is that only the amount of solute is going to decide the concentration? Now we are going to see a situation where the volume is changed. Your solution 3 is made with 3 grams of copper 2 sulfate and 200 cm cube of water, whereas solution 2 was the previous solution, 3 grams in 100 cm cube. What do you think? Which one has a greater concentration of copper sulfate? Obviously it is 2. What has happened to the solution 3? Even though both of them have the same amount of copper sulfate dissolved, but the 3 has a greater volume of solution, or more water is added, so now the concentration is less. From the previous experiment, we realize certain things about concentration. The first thing is the concentration is directly proportional to the amount of solutes dissolved. Second thing is it's indirectly proportional to the volume of the solution. Therefore, we can write an equation for the concentration like this. Using the equation we learned, now we'll compare the observations of the previous experiment. Before that, we need a small unit conversion to learn. Since we are using decimeter cube as the usual unit in chemical calculations, we need to know how to convert cm cube or the milliliters into decimeter cube. 1000 cm cube is equal to 1 dm cube. As a result, 1 cm cube is equal 1 over 1000 dm cubes. Therefore, if you are given centimeter cubes, cm cubes, you are going to divide it by 1000 in order to get decimeter cubes. Like this. You used 100 cm cube previously, so we divided that by 1000 to get 0.1 dm cube, and 200 divided by 1000 to get 0.2 dm cube. Your solution 1 gram divided by 0.1, so it's 10 grams per dm cube. Solution 2, 3 grams divided by 0.1 dm cube, 30 grams per dm cube. Solution 3, 3 grams divided by 0.2 dm cube, 15 grams per dm cube. Therefore, and this was the least concentrated due to the least intensity of the color. So you can understand it's 10 gram per dm cube. So it's not just the amount, it's not just the volume, the combination of these two, you find the concentration. So finally, if I define what the concentration is the amount of solutes dissolving a unit volume of your solution. That is what we need to use to compare the properties of solutions. If I give you the solution number 4 with some details, see whether you can guess the intensity of color, whether it's the highest, lowest or in between. You can do that by calculating the concentration. Solution number 4 is 3 grams of copper sulfate dissolved in 50 cm cube. The concentration can be expressed in moles per dm cube because the amount of solutes we usually measure in moles. Let's see how do we calculate concentration in moles per dm cube. Concentration is equal to the number of moles of solutes divided by the volume of solution. The unit of volume should be dm cube when you use this equation. The concentration that you get in moles per dm cube is usually known as molar concentration. We can write this equation using the symbols C equals N over V. We can rearrange it for more friendly version, N equals CV. Now let's see how can we do some calculations using N equals CV. Assume a solution is given to you by adding 2 moles of sodium hydroxide into 500 cm cube of water. So you can see this is your N, moles, and this is your V. You need to calculate then the concentration. So let's substitute these values into this equation. 2 moles equals concentration into, don't forget to divide this 500 by 1000 in order to convert that into dm cube. Now we can find the concentration. The answer is 4 moles per dm cube, which means you have 4 moles of solutes dissolved in 1 dm cube of your solution. Example number 2. Now we'll see how to calculate the number of moles dissolved when the concentration and the volume are given. Look at this example. 0.5 moles per dm cube HCl solution is given and it's a 50 cm cube of a portion. So always you read your question and point out the data given. This is concentration. Therefore, this is C. And this is volume. Therefore, this is V. Know where to substitute in your N equals CV equation. So the moles is what you need to find, and the concentration is 0.5 moles per dm cube into the volume. Again I emphasize, you need to divide this by 1000 in order to convert that into dm cube. Your final answer going to be 0.025 moles. So you have the concentration given, volume given, and the two values have been substituted to these two parameters. Don't forget to change the units of the volume to dm cube and do the calculation. Let's go to the next level of calculations. Don't forget, calculating number of moles is your center of all chemical calculations. Therefore, let's combine N equals CV and N equals M over capital M, that means mass divided by the molar mass, in order to do calculations. Look, this diagram represents the connection between these two. When you are getting a question, keep this diagram in your mind so that it's easy to analyze the question. The moles are connected to mass and are connected to volume of solution through these two equations. Suppose you are going to prepare a solution like this. We have 100 cm cube of solution. You are going to dissolve 1 gram of sodium hydroxide. And the question is asking you the concentration of the resultant solution. Concentration of the resultant solution. Let's analyze the question. Look, we are given mass and we are asked to find the concentration. So we know the mass and we have to find the concentration. You can clearly see the first step should be finding the moles, because we are here in this plan. So let me use N equals M over capital M in order to calculate the moles. The mass use 1 gram divided by, here we have sodium hydroxide. The molar mass of the sodium hydroxide can be calculated using the relative molecular mass, using the periodic table, using relative atomic masses, which are 23 plus 16 plus 1. So it's going to be 40 grams per mole. If you are not familiar with finding moles, starting from the masses, please watch the video where the moles and the masses have been explained. Right. So here we have 0.025 moles of sodium hydroxide dissolved in this solution. Then you are here, you know the moles. This was the step 1, and now you are here. Then the next step is going to find the concentration. So do you know moles? Yes. Do you know the volume? Here we are given volume, so we know this as well. Now we have to find C. So let's use N equals CV. Moles going to be 0.025 moles. Concentration is not unknown. The volume is, remember you need to substitute in dm cube. So you divide this by 1000 and then get it in dm cube. So you get your concentration will be 0.25 moles per dm cube. Unlike the previous calculation, you had 2 steps here. Why? I gave you the mass at the beginning, but I asked you to calculate the concentration. So there wasn't a connection straight away with mass and the moles per dm cube. Therefore, you need to convert your mass into moles and then moles into concentration. This mind map of calculation is really important for you to have it in your head when a calculation is given. Let's take another example. The situation is we need to prepare sodium hydroxide solution. Its concentration is 0.2 moles per dm cube. The volume we need to prepare is 250 milliliters or 250 cm cube. You are given a bottle of sodium hydroxide solid. What you have to do now? We need to measure a particular mass of sodium hydroxide and dissolve in the standard procedure in order to prepare the solution. So basically you need to find out the mass of sodium hydroxide you need to measure out from this to prepare that solution. Let's use our mind map of calculation. Moles, mass, volume. N equals CV, N equals M over capital M. Let's see what are the figures given as data. We are given the concentration of sodium hydroxide. We are given the volume of sodium hydroxide. So you can clearly see the first thing you can find is the moles of sodium hydroxide, since we know the volume and concentration. So we use those two values, 0.2 moles per dm cube into the volume is 250 divided by 1000 dm cube. Don't forget, 1 milliliter is 1 cm cube. You need 0.05 moles of sodium hydroxide. Now you are here. You need to find the mass. So we are going to use N equals M over capital M now. Moles we know 0.05 moles should be taken, and the mass that we have to measure is simple M. Molar mass is 40 grams per mole. I explained during the previous example how to do it. And the mass is going to be 0.05 into 40. It is 2 grams of sodium hydroxide necessary to prepare this solution. Very simple. You are given the concentration and the volume. You are asked to find the mass. Since we know N equals CV, we find the moles first. And the moles and the number of moles is connected to the mass through this equation. Therefore, I can find the mass. So my first step was to find the number of moles using C and V, and then use that moles here in order to find the mass of sodium hydroxide. So now you know how to prepare a solution with a given concentration. Let's see how do we actually do this in the laboratory. What sort of glassware to be used and what kind of methods that you need to follow. I am going to explain you how to prepare a standard solution. What is a standard solution? It is a solution that we know its concentration exactly up to certain level of precision. To prepare a standard solution, you need the volumetric flask. This is the volumetric flask. This is used to prepare a solution with high accuracy in volume. The mark over here shows the 250 cm cube. So how to use it, I will explain after measuring the mass of sodium carbonate needed. This is the anhydrous sodium carbonate solid available in the laboratory. We have to take the solid from this bottle and prepare the solution in the volumetric flask. Right. The mass of anhydrous sodium carbonate that we need to measure from this is 5.3 grams as we calculated earlier. Let me show you how to measure it. Now we measure sodium carbonate into a beaker. First we need to tear the balance so that we start from 0 grams. We need to measure 5.3 grams of sodium carbonate. This is anhydrous sodium carbonate. So we add the solid little by little until we get 5.3. Likewise, we add until 5.3 is obtained. Now we have 5.3 grams of sodium carbonate measured. The next step is to get this solid dissolved in water in the beaker itself. So we add little bit of water first and try to have the solid dissolve completely in the beaker. Remember, you measure the required amount of the mass of sodium carbonate. Now we are going to dissolve that in minimum amount of water. We are going to transfer this solution into the volumetric flask. So you have now added your sodium carbonate, but still little bit of sodium carbonate is left in the beaker, so we rinse it and then transfer that as well. And then we rinse the beaker and the funnel to get all your sodium carbonate transferred into the volumetric flask. Now your volumetric flask has all your sodium carbonate measured inside. Now we have to carefully add water until the solution level is increased. If the solid still remain, you can dissolve it before you are going to top up this mixture. Once we have added the solution until the neck of the flask, we are going to add water carefully until the water level goes up to the mark. You have to carefully add water when the solution level has almost reached the mark. Make sure the bottom part of the meniscus is just touching the mark. Now the water has been added accurately up to the mark. Then we put the stopper and turn it several times up and down in order to make the solution homogeneous. Here we have 250 cm cube of 0.2 moles per dm cube sodium carbonate solution accurately prepared. So in this video you learn concentration of solutions from the basics of concentration until you prepare a standard solution. Hope you enjoyed this video. You are now in a position to answer the tutorial number 1 about concentration. Thank you.